Welcome to the Unit 3 remediation packet. This is the guided practice. It says define the following terms. We have an atom. It's the smallest part of any element possible. Proton is a positively charged particle in the nucleus. Neutron is a neutral particle in the nucleus. The nucleus contains the protons and neutrons. It's at the center of the atom. The electrons are a negatively charged particle that surrounds the nucleus. An element is composed of just one type of atoms. Dmitri Mendeleev was the person who developed the first periodic table. Henry Moseley was the person who developed the modern periodic table. A nuclear reaction is a reaction that involves the nucleus and not the electrons. A fusion reaction is taking two smaller elements, creating a larger one, and releasing a large amount of energy. Fission is taking a very large atom and breaking it up into smaller atoms and releasing a large amount of energy. And then alpha decay is just the emission of a helium nucleus. Some ones that we missed: average atomic mass is the mass of all the naturally recurring isotopes. The atomic number is the number of protons. A chemical group that is on the periodic table, it's a column on the periodic table. And then valence electrons are the electrons in the outermost energy level. So jumping into this periodic chemistry, it says describe the significance of Dmitri Mendeleev's contribution to the periodic table. So Dmitri Mendeleev organized the first periodic table. He organized it according to atomic mass, and he was the first. Describe the significance of Henry Moseley's contribution to the creation of the periodic table. He organized the modern periodic table, which is organized by the number of protons, the atomic number. C, what part of subatomic particle organizes the periodic table? That would be the proton. Nucleus, periodic table, all of that stuff. So it says, as the periods increase on the periodic table, how do the atoms change? So as we move on the periodic table, a period is a row. So as you move down the rows, you are increasing the number of energy levels that that element has. B is how can you determine the number of protons by looking at the periodic table? You look at the atomic number. It is the number on the top of the symbol of the element on the periodic table. And that answer C, where is the atomic number located on the periodic table? It's above the element, the symbol of that element. So nuclear reactions. What is the difference between a nuclear reaction and a chemical reaction? A nuclear reaction involves the nucleus. A chemical reaction involves the valence electrons. B, it says describe how a fusion reaction happens and where someone might find a fusion reaction. A fusion reaction, taking two small atoms, combining them into a larger one. Where can we find a fusion reaction? Well, that is the sun. A day without fusion is a day without sunlight. So, C, it says describe how a fission reaction happens and where someone might find a fission reaction. A fission reaction involves a large nucleus, like, say, uranium, and it's broken up into smaller atoms. So, a fission reaction, that is what's happening at every nuclear power plant right now. Looking at periodic families, it says what is the name of the periodic family in column 17? So when we're looking at the columns on the periodic table, the column is called a family, and the name of the family on 17 is called the halogens. B, it says what are the elements in the periodic family, or how are the elements in the periodic family similar? If you're in the same family, you have similar characteristics. Just like periodic families, they have similar chemical characteristics. See, it says as you are moving down the column of the periodic family, what changes with the atom? Well, what changes, they have similar chemical properties, but as you move down, you're moving down the period, and so therefore you're increasing the energy level. Looking at a Lewis dot diagram, a Lewis dot diagram represents what subatomic particle? And that would be the valence electrons. B, it says determine the number of valence electrons in calcium. Well, calcium is in group 2, meaning it is an alkaline earth metal, and so therefore it has two valence electrons since it's in group 2, and so therefore um, it just has two valence electrons. So C, it says write the Lewis dot diagram of oxygen. Well, you have to know how many valence electrons oxygen has. And since oxygen is in group 16, it has 6 valence electrons. So we need to know that group 1 has 1 valence electron, 2 has 2 valence electrons, and then 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8. So oxygen has 6. So we just put an oxygen, and then we just put 6 dots. 1, 2, 3, 4, 5, 6. And just put one at a time around until we get one that looks like that.